In this lecture, I'm going to discuss about the unilateral Laplace transform, and we also do some problems on the unilateral Laplace transform. So what is this unilateral Laplace transform? So if I compare with the whatever we discussed now up to previous lecture, that is generally bilateral transform or Laplace transform, and what we need to discuss is unilateral transform. So bilateral means, so we can say it is two-sided Laplace transform, right? Two-sided means the limits will be minus infinity to plus infinity. So that's why it is called either bilateral transform or two-sided Laplace transform. Now in case of unilateral, so it will be one-sided transform, right? So it is one-sided or single-sided, right? So that's why it is called unilateral, and the limits will be from 0 to infinity, right? So that's why it is called one-sided only. So if we take the graph like this, so this is the limits minus infinity to infinity. So this whole we can say bilateral Laplace transform, right? So up to 0 to infinity it is unilateral, right? So that is the major difference between this bilateral and unilateral transform. Now what we need to see is what is the application of this unilateral Laplace transform. So when we analyzing the causal system, so we can use the unilateral Laplace transform, because the causal systems are one-sided only. Because if I take some h of t will be 0 for t less than 0, and from 0 to infinity the value will be there. So the causal system is h of t is 0 for t less than 0. So to analyze this causal system, so we can use the unilateral Laplace transform. Similarly, when we analyze the differential equations with non-zero initial conditions, so this is the important point. So when we saw the differential equations in the bilateral Laplace transform, we did not consider any initial condition, that means zero initial conditions. But when we go for the unilateral Laplace transform, so the system which having the non-zero initial conditions, that means the system is initially not at rest. That means some processes already happened and it is having some conditions, initial values. So using those initial values, we have to analyze the system. So there we can use the unilateral transform to analyze those differential equations and systems, right? So this non-zero initial conditions means the system is initially not at rest. So it is having some initial values. The system is initially at rest means, so it should be, or it is about to process, right, from 0 to infinity or minus infinity to infinity. So initially rest. So now the moment we give input, it will produce some output. But some systems with already some process is already done, that means it is having some values. Now the moment we give input, now it will analyze depending on this initial values, right? So when we want to analyze those differential equations with non-zero initial condition, the unilateral Laplace transform is helpful. That is the two applications of this unilateral Laplace transform. Now we'll see how to find the unilateral Laplace transform like this. So I will write for the first bilateral Laplace transform of any signal x of t. So Laplace transform x of t is equal to x of s, and the limits will be minus infinity to infinity x of t into e power minus st dt. Now when it comes to unilateral Laplace transform, right? So the notation is somewhat different, but anyway, you don't require that the different notation. So unilateral means you can use UL, right? Unilateral Laplace transform of x of t, and here we can use different something like this. x of s is equal to, the limits will become 0 to infinity. That is the only difference we will get. e4 minus st dt. So in the textbook they will use the 0 minus, so we can use 0 minus also, right? So 0 to infinity or 0 minus to infinity. So this is the unilateral Laplace transform expression. Now what is the difference we will get? Suppose if I take some example, x of t is equal to some e power minus at u of t. Now this signal is 0 for t less than 0. So whenever t less than 0 there is no values of any signal, the unilateral and bilateral Laplace transform will be equal, right? So whatever we get the bilateral Laplace transform, will get the same for unilateral Laplace transform also. So that is x of s is equal to 1 by s plus a, and ROC is also will get same, the real of s is greater than minus a. So unilateral Laplace transform also will be same, right? Something like this I'll write here. So I'll get 1 by s plus a only, real of s is greater than minus a. The difference we'll get in this example. See, suppose some x of t is like this, e power minus a of t plus 1 into u of t plus 1. Now if I write the bilateral Laplace transform, we know that by the shifting procedure, so it will be e power s by s plus a, right? So and ROC is a real of s is greater than minus a. This is we know from the bilateral. But when it comes to unilateral, so we'll get different Laplace transform. Unilateral, so the x of s is equal to, it will become 0 to infinity. And what is the signal? It is e power minus of a t plus 1. So this is 1. So actually it should be minus 1 to infinity, but the unilateral will become 0 to infinity. And here minus e power minus a into t plus 1 into e power minus st dt. Now e power minus a is common, and e power minus of s plus a into t by minus of s plus a, right? So I hope you know this how I did. So e power minus a is constant, so it is common. E power minus at into e power minus st. So I have taken minus t common, so it will become s plus a. The limits will be 0 to infinity. So what is this value? 1 by s plus a, assuming that the ROC real of s should be greater than minus a, right? Now see, what is this e power minus a by s plus a? This is some x of s, unilateral Laplace transform. See this here, e power s by s plus a, and here we are getting e power minus a by s plus a. That is the difference between this unilateral and bilateral Laplace transform. That means even though it is starting from minus 1 to infinity, but from the unilateral we should take from 0 to infinity. That's why we will get different answer, right? So that's why whenever we will do the time shifting, advanced we will get same, but when it is, sorry, it is not, for advanced we will get different answer, for delayed we will get same answer, something like this. I'll give for you assignment. So go for like this, e for minus of a t minus 1 into u of t minus 1. So I'll get x of s, that is bilateral s, e power minus s by s plus a, and the unilateral Laplace transform also I will get e power minus s by s plus a. And ROC will be same, real of s is greater than minus a, right? Now you do this anyway we know there is just shifting by delayed e power minus s by s plus a. But what happens when we find the unilateral Laplace transform? We will get same, because this will start from 1 to infinity, right? So whenever it is a causal signal or causal system, we will get unilateral and bilateral transform are equal, right? That is you verify on your own. Now we need to discuss the properties of the unilateral Laplace transform, right? Or Laplace transform. Now we need to discuss the properties of the unilateral Laplace transform. Now all the properties are same as for the bilateral Laplace transform, but three properties will change. That is the differentiation in time domain. Now, what is the differentiation in time domain is, suppose x of t is having a Laplace transform x of s in bilateral, right? So d by dt of x of t will become s into x of s. These two are in bilateral Laplace transform, but this is not same in unilateral Laplace transform, so that we need to discuss. So first I will write this d by dt of x of t, this is unilateral Laplace transform. This will become s into x of s minus x of 0 minus. This 0 minus is initial value at 0, right? Now if I go for a proof of this one, that is a proof. So we know that, so x of t is having a Laplace transform, some different notation will use x of s. Now if I want to find the unilateral transform of d by dt of x of t, so what is the formula? 0 to infinity, or we'll take 0 minus to infinity, and this here will become d by dt of x of t into e power minus st dt, right? So this is actually we are having some different signal g of t, or simply d by dt of x of t. Now if you see, dt and this t will be cancelled. Now this integration will become 0 minus to infinity e power minus st into d of x of t. Now from the mathematics we know one integration by parts, right? So there are two different equations or formulas will be there, that is some a to b, suppose a to b, and some u into dv is there, right? So what is this formula is u into v minus integral v du, right? So this is the formula from the mathematics. Some u into dv is there, so it will be uv minus integration of v into du, and anyway limits we need to substitute. It is a to b, here also a to b. Now when we see this expression, so what is u and what is v we need to discuss. So u is equal to e power minus st, but we need du, so first we'll differentiate this one. Du is equal to e power x, means e power x only, into differentiation of x, so it will become minus s. Similarly, so what is v? So from this, d of v, so v is equal to x of t, right? So v is equal to x of t. Now see from this integration, so what is the value here you will get? So 0 minus to infinity e power minus st d of x of t is equal to uv e power minus st into x of t, and the limits are 0 minus to infinity minus integration of 0 minus to infinity. What is v? V is equal to x of t into du. Now see here, so I forgot to mention here, du means, so with respect to t here, no, so we'll get dt also, right? So e power x into, e power x means e power x. Again we need to differentiate the x value. So with respect to t means we'll get minus s into dt here, right? So that t, see, so du means minus s into e power minus st into dt. Now if you see here, the limits, if I substitute, e power minus infinity will become 0, 0 minus e power 0 means 1, and it will become x of 0 minus minus, so minus minus will become plus s into 0 minus to infinity x of t into e power minus st dt. Now what is this? This is nothing but unilateral Laplace transform. Now this will become s into x of s minus x of 0 minus. So this is the, what is the unilateral Laplace transform of x of d by dt, sorry, d by dt of x of t. So that is this one. So So d by dt of x of t will be s into x of s minus x of 0 minus in unilateral Laplace transform, because we have to deal with the non-zero initial conditions, right? So if you don't remember this proof, it's not required. So s into x of s minus x of 0 minus. Now suppose there are second order differential equation. So d square by dt square x of t. So for this, what is the unilateral Laplace transform? So s square into x of s minus s into x of 0 minus x dash of 0 minus, right? We'll get one more extra term, that is x dash of 0 minus. So what is this? X dash of 0 minus is nothing but d by dt of x of 0 minus. Similarly, cube means we'll get cube, then square, then s, then x double dash also will get, and so on, right? So this is the differentiation in time domain property. Similarly, we can have the integration in time domain, that is 0 minus to t some x of tau d tau is there, right? So what is the Laplace transform? Is x of s by s, same as in bilateral, but when the limits will become minus infinity to t x of tau d tau, the Laplace transform will change. Unilateral x of s by s plus, so minus infinity to 0 will get some initial value, that is minus infinity to 0 minus x of tau d tau by s. That is a change we need to remember. If it is 0 minus to t, simple as or same as the bilateral Laplace transform, but the limits minus infinity to t x of tau d tau, and we need to find the unilateral. So x of s by s plus the initial value will also add. That we need to remember. The last property here is integration in s domain. So how? So this x of t is having unilateral transform as some x of s. Now if x of t by t is there, right? In the time domain it is 1 by t into multiplication x of t into 1 by t. So in the Laplace domain, this will be s tends to infinity x of s ds. So this what do you call it? The property is from the mathematics. So from, if I divide with a t in the time domain, so we need to integrate in the s domain, right? So that we need to remember. Previously you may got 1 or 2 times this question, right? So that we need to remember. Suppose Laplace transform of some sin t by t is there, so I think is given. So what is the Laplace transform? So that there we need to use this property that we anyway will see in the when we do the problems. Now one more property we need to discuss, which is differ from the bilateral Laplace transform. In bilateral Laplace transform, x conjugate of t in Laplace domain is also x conjugate of s conjugate, right? But in the unilateral Laplace transform, this will be slight change will be there in this unilateral so here x conjugate of s only. So s conjugate will not be there, only the x conjugate, right? So this we need to remember. And so we should not apply the time shifting property, because in our time shifting, that is x of t minus t naught, so we'll get unilateral and bilateral same, that is e power minus s into t naught x of s. But x of t plus t naught, right, for the bilateral we'll get as something like this, e power s naught into x of s. But unilateral it is not same, t plus t naught, so it is not equal to e power s into t naught into x of s in bilateral, right? So that we need to remember. The remaining properties are all same, that is scaling property and convolution property, right? And shifting in s domain, both are, I mean the through properties, the remaining initial value theorem, final value theorem, everything is same. Only the difference is this of 4-5 properties. The first property is differentiation in time domain. The second property is differentiation in integration in time domain. The third property is integration in s domain. The fourth one is conjugation The fifth property we should not apply is time shifting, right? For this one we can apply, but this one we should not apply the same as bilateral Laplace transform, right? So remember these 4 or 5 properties in unilateral Laplace transform. The remaining, that is initial value theorem, final value theorem, right? Differentiation in the S domain, then time scaling, then shifting in the S domain. All the properties will be same as in the bilateral Laplace transform, right? Now we'll try to solve this question, which is the differential equation is given and the condition is, so this is system is characterized by the differential equation and the system is initially at rest. So find the system function and the impulse response. The system function is nothing but h of s. Impulse response is nothing but h of t. Now, so initially at rest means the unilateral as well as the bilateral Laplace transform will be same. So directly it will become s square into y of s plus 3s into y of s plus 2y of s is equal to x of s. Now, what is the output response by input response? Is nothing but h of s is equal to, so there is no, the constant is only 1 here, so directly 1 by the remaining, the coefficients will be of y of s is s square plus 3s plus 2, right? This is the system function. Now to find impulse response, that is h of t, we need to take the inverse Laplace transform. It may be unilateral, it may be bilateral, both are same, but we need to make this one is a fractions. We need to find the roots. So simple, this will become s plus 1 into s plus 2, right? So if we multiply s square plus s plus 2s, so 3s plus 1 into 2. Now this is h of s. Now what we need to do, partial fractions. So it will become 1 by s plus 1 minus 1 by s plus 2. Randomly we can take like this and we have to prove that it will become 1. See, if it is like this, s plus 2 minus s plus minus of s plus 1. So s will be cancelled, 2 minus 1 will be 1. So when you do so many problems, you may find that directly we can write like this. To make, see, we can write some arbitrary values we can take, and to make 1 here, so how to make, suppose if you are able to multiply with 2 here, then it will become 1 or as something, right? So that by practice it will come. Or you go with the standard procedure, a by s plus 1 plus b by s plus 2, finding a and b, you will get same, right? Now we know that if I take the inverse Laplace transform, the it will become h of t, and it will have so many conditions. Real of s is greater than minus 1, minus 2, less than minus 1, less than minus 2. But I will find for real of s is greater than minus 1. Whichever is smaller, we will get the common ROC like this. So what is the value we will get? E for minus t into u of t minus e for minus 2t into u of t. And the ROC is this, right? So because it's a unilateral, so if they ask unilateral, right? So real of s is greater than minus 1, you will get same, but the other conditions we may get different values, right? So that is about this one, because the unilateral will applicable for the causal systems. It will be 0 to infinity, right? So that is about this problem. Now we'll solve this question. So this question is same as the previous one. The differential equation is same and the initial conditions are also same. And if they give some x of t as u of t, now we need to find the output response y of t. Now, okay, I'm going directly. So from this, what is y of s by x of s? The constants here is 1 and here, so initial conditions are 0. It will become simply s square plus 3s plus 2. But we need y of t. So what is y of s is equal to 1 by s square plus 3s plus 2 into x of s. Now x of t is given, that is u of t. So from this, what is the Laplace transform? Simply 1 by s. So this will become 1 by, if I take fractions for this one, so this will become s plus 1 into s plus 2 into x of s means 1 by s. So it will be s. This is the y of s. Now how to do? Using partial fractions. So a by s plus b by s plus 1 plus c by s plus 2, right? So we may get direct, we may not get directly, that's why I have it like this. So what is a value? When s is equal to 0, we'll get a value as 1 by 2. So this will become 1 by 2 by s. Why? If s is equal to 0 means it's a fraction is s equal to 0, so it will not be there. So 0 0, so 1 into 2, 1 by 2. Now to find b, s is equal to minus 1, we need to substitute. So this will not be there. Minus 1 plus 2 is 1, and this is minus 1, so it will be minus 1 by s plus 1. Next, for s is equal to minus 2, it will not be there. Minus 2 plus 1, minus 1, minus 2, so minus will be cancelled, so this will become 1 by 2 by s plus 2. Now what we need to do, simply take the inverse Laplace transform. Again we are going for real of s is greater than minus 1, right? So for this one, real of s is greater than 0, real of s is greater than minus 1, real of s is greater than minus 2. The common ROC is minus 2, minus 1, this is 0. So what is the common ROC we will get? Real of s is greater than 0. Now what is this? It's a causal only. So what is y of t? 1 by 2 into u of t minus e for minus t into u of t plus 1 by 2 into e for minus 2t into u of t. Right? So what is the common ROC we need to take? So in the previous example we have taken real of s is greater than minus 1 because 1 by s is not there. But in this case 1 by s is there. The common ROC is, so one is like this and one is like this. The common ROC between real of s is greater than 0. For all three conditions it should satisfy. So that is this y of t. Right? So this is about this one. Next, one more example we'll see is the properties. So Laplace transform of sin t by t. They will not mention the unilateral or bilateral, something they will give like this, sin t by t. The moment sin t by t is given, we have to go for the unilateral Laplace transform. Now what is the sin t Laplace transform? We know that it is b by s square plus b square, that is 1. Now what is sin t by t Laplace transform? So we know from the integration in the s domain, so it will become s tends to infinity and x of s, that is 1 by s square plus 1 into ds. Now what is this value? We know that integration of 1 by x square plus a square dx is equal to 1 by a tan inverse x by a, the formula from the mathematics. So this will become 1 by a means 1 only, so it will become simply tan inverse s. And what are the limits? S tends to infinity. So tan inverse infinity means pi by 2, 90 degree minus tan inverse s. Right? So this is the Laplace transform, this one. And this can also be written as cot inverse s. Pi by 2 minus tan inverse s can also be written as cot inverse s. So either this one or this one will be there in the answer. So cot inverse s or pi by 2 minus tan inverse s. Similarly, some signal by t is there, we need to integrate in the s domain. Right? So this is about some problems on unilateral Laplace transform. In the next lecture we will discuss the gate questions. Right? That is we do in the next lecture.